Okay, Chapter 4, Lesson 3. Write linear equations in point-slope form. Okay, we're adding another form. I'm so sorry, but we'll practice these forms. This is the last thing we're adding for a while. We're going to take a couple of days of review. So let's talk about point-slope. Again, the key here is point-slope. Like slope-intercept has the slope and the y-intercept. Point-slope is going to have a point from the line, any point from the line, and the slope of the line. So that's kind of the key of how you can tell the difference. So here's the key concept. Point-slope form. So when you're given the slope of a line and one point on the line that is not the y-intercept, you can use point-slope form to write the linear equation. Okay? The equation of a line with a slope of m, because that's always our slope, and passing through the point x sub 1, y sub 1 is written as follows. Now this y is black because that's the y that's in our equation. The y sub 1 is the y coordinate. So y minus the y coordinate from our point equals the slope m times, now this x is black because it's the x that is in the equation, and this x is the x sub 1, which is the x from our coordinate, from our point. So that is point-slope form. Y minus y sub 1 equals the slope times the quantity x minus x sub 1. So here's our example. If our slope was -3 and we were passing through the point 2, -4, we would write our equation like this. Y minus the -4, which is my y coordinate, equals my slope -3 times the quantity x minus 2, which is my x coordinate, because the minus is there and my x coordinate is a +2. And again, the minus is here and my y coordinate is a -4. It's kind of like our slope formula, sort of. It has that understood always minus, even if our coordinate's negative. Okay, so here's an example. Example 1, write an equation in point-slope form of the line that passes through the point 4, -3 and has a slope of 2. So just like what I just showed you, here's your point-slope form. So keep that at the top of your page if you want to, or somewhere when you're doing your assignment. And you're going to substitute 2 for m, because that's your slope, 4 for your x, because that's your x coordinate, and then -3 for y, because that's your y coordinate. So here's what we do. So how did this become a +3 when our y coordinate is a -3? Again, remember, it's y minus the y coordinate, which is -3. So those two negatives go work together to make this a positive. So that would be your point-slope form. That's it. That's all there is to it, just substituting in at this point. Okay? All right, so now our next example is to graph an equation in point-slope form. So the first thing to do is, since we know it's in this form, you know that the line has a slope of 2/3, because look at where the 2/3 is. It's in the slope's place, and it passes through the point +3 and -2. Now, how do we know this is a -2 and this is a +3? Notice it's the exact opposite signs. My x-coordinate, while there's a minus in front of it, that means my x-coordinate is positive. And my y-coordinate has a positive sign in front of it, so that means my y-coordinate is negative. Because think about it, it was originally written like this. Okay, equals 2/3 times x minus 3. So we know the x-coordinate's positive because the minus is given in the equation, and we know the y-coordinate's negative because they canceled out to make it positive. Okay, and so there's what we know. So now we can graph it. We can graph the point 3, -2. So we go 1, 2, 3, down 2, because again, when we're graphing a point, we graph x first, then we graph y. Slope is just the opposite. So here's our point, 3, -2. My slope, though, is 2/3. So my slope is opposite. I go up first and to the right 3. So from this point I graphed, from this point I got from the equation, I go up 2 over 3, graph another point. If I wanted to, I could go to the left 3 and down 2 and graph another point. And I could do that all day. Up 2 to the right 3, graph another point, and draw my line. Okay? So find your point, use your slope, and graph your second point. All right, write an equation in point-slope form of the line that passes through the point 9, 4, and 17, 6. So use the first point to write the equation. So we're going to use this one when we come back to write the equation. But first we have to find the slope between the 2 points. So I'm going to do y sub 2 minus y sub 1. I'm going to do 6 minus 4 over x sub 2, 17, minus 9. Okay, 6 minus 4 is 2. 17 minus 9 is 8. So my slope reduces, 2/8 reduces to 1/4. So there's my m. Okay, use the slope and the first point to write the equation. So here's my equation. Y minus y sub 1 equals m times x minus x sub 1. So let's substitute. My y sub 1 is 4, so it's y minus 4. My m is 1/4. My x sub 1 is 9. There's my equation. Okay. All right, use point-slope form to write an equation. Write an equation in point-slope form of this line. So the first thing to do, let's find our slope. So we go up 2, so our slope is plus 2 this way, and negative 2 this way. So it's positive 2 over negative 2, which is the same as negative 1. So there's my m. Okay. The notes here are going to show you to use y sub 1 minus y sub, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. They get the same slope. But if you have a graph, you are welcome to count, as long as you know how to do this if you just are given 2 points. Okay? So we have our slope of negative 1, so we're going to use one of the points. It doesn't matter, they're going to show you both points. So my y sub 1 is my 3, my x sub 1 is my negative 1 in this case, and my slope is negative 1. So notice there's not really a negative 1 out here, it's an understood negative 1. They just put the negative in front, but that's an understood negative 1 in front of that parentheses for my slope. My 3 plugs in here, my negative 1 plugs in right here, making it a positive 1. Method 2 just uses the other point that they gave you. So same idea. There's my point slope. The y stays the same. Here's my y sub 1 for this case. My slope is still negative 1. And here's my x sub 1 for this case. Okay. All right, last one. Write a real-world linear model from a table. We've done tables. We're going to find the rate of change. That's all we're going to do. So we're going to look at our change in x. Each time it's increasing by 2. And my change in y, each time it's increasing by 100. Okay, so my rate of change would be $100 for every 2 people, which reduces to $50 per person, or my rate of change is 50 over 1. So just showing you this. We're going to do this on the next page, but I'm just showing you. Find the rate of change. Because the cost increases at a constant rate of $50 per person, and I showed you how we knew that on this last page, the situation can be modeled by a linear equation because it's a constant rate. Linear equations always have a constant rate of change. So we're going to use our point-slope form to write the equation. So let C be the cost in dollars, P be the number of people. So this is like my Y, because my cost depends on how many people, and this is like my X. And the data pair that they got, just so you know, it came from the chart. They just chose a data pair. Oh, I'm going the wrong way. They chose a data pair right here. They chose the 4 and the 250. So that's where they got their information. They chose this X and Y coordinate pair. Just wanted to show you that. Okay. And so they use the point slope form. And this time, instead of y minus y sub 1, they used cost minus cost sub 1, which would be here. Sorry, that was kind of crazy there. Cost, there's my cost sub 1, and there's my people sub 1. So we just substitute in. My C minus 250 equals my $50 per person times the P minus 4. So there's my equation. Solving for C, I end up with my cost being $50 per person plus $50 just upfront fee. Now, look at this. This looks like slope-intercept form, with this being my slope, this being my y-intercept. So obviously we can take point slope form and we can solve for slope-intercept form. All right, you can stop the video. Do your guided practice, please.